So today we're going to be covering intersections that do not have any signal control. So we're going to take a look at the different conflicts that exist within Vissim and how to use conflict areas, priority rules, and stop signs. So within Vissim, the vehicles that are on the same link, they will observe each other and they can follow each other and pass each other. But if there's a vehicle traveling on a different link, those vehicles don't interact in the same way. So for any vehicles that are on different links, the right-of-way will actually have to be defined in order for those vehicles to see one another and react appropriately. So in general, there are three different types of conflicts: merging, branching, and crossing. And so in Vissim, the merging areas are going to exist if you have two connectors that are going to the same link, or if you just have a connector that's connecting to a link. And then in the branching areas will occur either, again, if you've got two connectors kind of branching off from a link, or if you have a single connector going from one link to another link. And then in the crossing case, these conflicts will exist at any location that two links or two connectors cross one another. And so these are going to be the situations where we'll have to make sure that all of the right-of-way is defined within Vissim so that those vehicles can interact appropriately. So again, in Vissim, any yield location can be modeled using either the conflict area type or the priority rule type. And then in addition, there's also a stop sign object that can be used to model any of those stop locations. And here's just a quick list of kind of the do's and don'ts when using these type of objects. So all of the conflict areas and the priority rules should never be used together. Just depending on the condition that you're modeling, you'll just want to use one of those over the other. And we'll kind of talk about that a bit more later. And then whenever you're modeling any stop controlled movements, the stop signs will need to be used with either the conflict areas or priority rules. The stop signs in and of themselves, they actually don't add any type of conflict avoidance. So those should not just be used alone, especially if you're modeling two-way or all-way stop controlled intersections. You will have to have either the conflict areas or priority rules in addition to the stop signs for those intersection types. All right, so first let's just go ahead and take a closer look at the conflict area type and how we can configure those. So all of the conflict areas are automatically displayed throughout the network as long as you have that conflict area object selected. And so these are going to show up at any of those merging, branching, or conflict areas. And by default, all of the conflict areas are going to be set as passive. And so these will all show up as yellow. And when they're in this passive state, the vehicles will not have any impact on each other. They'll just basically ignore each other and just continue on their way. So for all of these, they're just automatically defined, and then we can go ahead and update them as needed. And the conflict areas, since they are automatically generated, these are much easier to edit than priority rules, and these are going to be recommended to be used in most cases, especially if you're modeling just like a two-way stop or any vehicles that are kind of crossing like a main intersection or for any permissive turns. So in order to configure the right-of-way on a conflict area, you'll just want to make sure you have that conflict area object selected in the network object toolbar. And then you can go ahead and just left-click on one of those yellow passive conflict areas. And then you can either update that right-of-way if you right-click to open up the context menu. You can then set the status in there to determine which direction will have the right-of-way. Or you can also just press Control and right-click, and if you keep doing that, it'll just cycle through each of these different states, and then you can just visually see which direction you'd want to have the right-of-way, and then you can just release all the buttons to leave that in that state. And then you can also edit the status if you view all of the conflict areas together within the list, So if you right-click on the conflict area network object and then click Show List, the list will then open up at the bottom of the window here, and you can see there's going to be a column here for status. So if you select any particular conflict area, you can also update that status from this drop-down menu. And then this window, also this list window, contains all of the different conflict area attributes, which we'll talk about a bit later. But this is where you can go in and edit any of these particular attributes for a conflict area. All right, so here's just a list of the different statuses that exist for each of the conflict areas. So all of the yellow ones, these are going to just be passive. So these are basically just inactive, and the vehicles will ignore one another and just continue traveling through the network. So in this case, both directions will just show up as a yellow box. And then if both of the conflict areas are set to red, this will typically be the case for any branching conflict so that the vehicles can see one another and won't overlap with each other. And in this case, for any of these undetermined conflict areas, the vehicles will just come on a first come, first served basis. So there's no set priority in that case. And then in the other two, where either 2 waits for 1 or 1 waits for 2, in this case, the green areas are going to indicate the main flow. And so these vehicles will have the right of way. And then any red area will indicate that minor flow that's going to yield to the vehicle in the major flow. And so any vehicle that's in that minor traffic stream is going to calculate whether there's a large enough gap in the main stream to enter. And then if not, that vehicle will end up waiting until that vehicle has passed and then continue traveling through the network. Okay, so now we're just going to go through all of the different parameters and attributes that are associated with conflict areas. And so again, all of these can be edited directly within that conflict area list if you just open that up, and then you can change any of these attributes. So the first parameter here is the link 1 and link 2 visibility. And so this is the distance that as a vehicle is approaching, they can actually see that vehicle on the other link. So if the yielding vehicle here, we've got this blue vehicle on link 2. So as this vehicle is approaching, when it's outside of that particular range that's been set, and it's still quite far away from the conflict area, it's going to prepare and plan on stopping at that conflict area. And then once it's inside this range and has reached that distance, that's when the vehicle will be able to actually see the other vehicle on the other link and can then start to interact with that vehicle. So as the vehicle approaches, it's then going to determine if there's a sufficient gap to continue going through that conflict area, or if not, in that case, it's just going to yield and wait until that vehicle has passed and then continue on. And then the next attribute here we have is the front gap. And this is going to be taken into account for any of the merging or crossing cases. And so this really represents the minimum gap time between the rear end of a vehicle that's going to be in that main stream and then the front end of the vehicle that's in the minor stream. And so based on this gap, this will determine when the vehicle is allowed to continue on and proceed through that conflict area. So you can see here in the top case, this red vehicle is actually going to yield and wait until the vehicle has finished passing through the conflict area. Whereas in the bottom case, this blue vehicle has a shorter gap time. So in this case, that vehicle will enter a bit earlier. And so again, when vehicles are evaluating this time, the yielding vehicle is just going to slow down as it approaches the conflict area and then check and see whether that min gap time has been met or not. And then if the vehicle does have to wait, it's going to look at the vehicle in the major traffic flow. And once it has completely left that conflict area, then the yielding vehicle will enter and continue on its way. All right, and then for the rear gap, this is only going to be used for crossing cases. And this is actually going to represent the minimum gap time between the rear end of a vehicle that's in the minor traffic stream and then the front end of the vehicle in the major traffic stream. And so this is going to be the time basically after that yielding vehicle has left that conflict area before that next vehicle is allowed to proceed and enter into that area. And then we also have a safety distance factor. And this will actually just apply kind of a temporary update to the main safety distance parameter that those vehicles will be using. So they will just temporarily basically have this factor applied and then go back to using their regular safety distance factor. And so this factor, again, was just going to be multiplied by its normal desired safety. And that vehicle is going to try to determine that minimum distance that yielding vehicle has to keep as it's entering in that conflict area. So you can see here for the red vehicle, this has a higher safety distance factor. So in this case, it's going to wait for the vehicle in the major traffic stream to proceed all the way through before it enters. Whereas the blue vehicle directly below it has a shorter safety distance factor. So in that case, the vehicle is allowed to continue on and enter into that major traffic stream prior to this darker blue vehicle behind it. And then also for the conflict areas, we can also set an additional stop distance. So you can see here that sometimes when the conflict areas are placed in the network, they might not be directly located at the actual stop bar where the vehicles need to stop and wait. And so this attribute here is just going to set some additional distance where the vehicle can wait upstream of that conflict area, and then they can yield back here and then continue on once they have that right of way. So this will just allow you to kind of set that distance. And it is important to note that when you do set this distance, that as the vehicles, once they evaluate that conflict area, they will continue going and proceed once they do have that right of way. Okay, and then we also have these two parameters here, observe adjacent lanes and anticipate routes. And observe adjacent lanes is just going to be a checkbox that you can turn on or off for a particular conflict area. So in this case, the observe adjacent lane is only going to be for merging cases. And this will be for any vehicle that's in the minor traffic stream that's going to be entering the major stream. They're going to take a look not only on the lane they're going to be entering, but also on the adjacent lane to see if any vehicles are wanting to change lanes into that conflicting lane. So they'll consider not only that current lane they're going to, but also the next lane just to kind of see vehicles on both of those lanes and see where they're traveling to. And then for anticipate routes, again, this is also for the merging cases. Essentially what this will do is you'll be able to set a percentage of yielding vehicles that are going to account for the routes of vehicles that have the right of way. And so these vehicles will be able to determine whether the approaching vehicle is going to either continue traveling or if it's actually going to make a turn and not reach that conflict area at all. And so this can be particularly useful when modeling roundabouts. For example, this red vehicle that's going to be entering the conflict area, they'll essentially look ahead and they can see whether this vehicle is going to keep going into the roundabout or if it's actually just going to turn off and not come into conflict with them at all. And so those vehicles will be able to proceed a bit sooner, whereas if they didn't know the route, they would just assume they were going to be coming that way and would maybe wait a bit longer than needed in those cases. All right, and then finally, we also have this avoid blocking the major or minor flow. And this is actually two separate parameters, one for the major flow and one for the minor flow. And if you do have this blocking turned on, what will happen is when the yielding vehicle is evaluating this conflict area, if it's not able to drive all the way through it without stopping, then that vehicle will not enter that conflict area. So it'll essentially, you can see here, the blue vehicle here is just waiting because it knows it can't make it all the way through due to the backup that's occurring. So that vehicle is just going to wait until it can make it all the way through the conflict area and not block any of the other road. And so again, both of those do have separate parameters, so you can adjust those as needed, whether if you don't want vehicles to block both or either the major flow or the minor flow. And there are also a few parameters, the front gap, the rear gap, and the safety distance factor, that can be edited by vehicle class. So you can have different settings if you need to, just based on the vehicle class. So if you have that conflict area list open down at the bottom of the network editor window, you can change the child list drop down here. By default, the child list will not be there. So if you just change that drop down to gap, then it'll open up this child list over here on the right hand side. And then this will allow you to further specify the particular vehicle class, and then each of the front gap, the rear gap, and the safety distance factor for that particular vehicle class. So this just allows you a little bit more configuration if needed based on that different types of vehicles using that conflict area. Okay, and then conflict areas can be tedious and quite time-consuming to add into the network, especially if you have a lot of intersections kind of lined up side by side. So starting in Vissim 2020, we started adding in this automatic generation process. So if you take a look at the network editor toolbar on the left-hand side, at the very top, there'll be an option with a little triangle with a signal on it. And so if you select that, this will allow you to define the major flow and set those conflict areas automatically. So once that's selected, it will open up this window here where it says define major flow. And then you can choose that option at the top to set conflict areas. This option can also be used to create some two-stage controllers as well. But in this case, we'll just be taking a look at just setting the conflict areas. And then once you have those selected, you can then click on the start point where you want to start adding those conflict areas, and then you can move the mouse to the end point to end that definition, and then you can just left click on that point. And you'll see here that in this case, the major flow roads are going to be highlighted in green. So you'll see that those will show up here just to indicate that that's going to be the major flow, and so all the conflict areas will have their right of way that in that definition. And then once you have that major flow defined, you'll see here the two-stage controller in conflict area window. Once you have that set, there'll be a green check mark you can select down here at the bottom. And then once you check that, you'll see here that those conflict areas have been all set and are predefined here in all of these cases. And so you can then at least easily check these, and you can change anything if you do need to make any further fine-tuning or adjustments. Okay, so now we're going to move over into the priority rules section. And unlike conflict areas, the priority rules are not generated automatically, and they're not predefined at all. And so these do take a bit longer to code, but they can be more flexible than conflict areas. And priority rules are especially useful if you are modeling an always stop controlled intersection. And they're also useful if you are trying to prevent any spillback that's occurring, particularly with signalized intersections. You can kind of set some rules up so that the vehicles will stop at a particular location and not proceed into the middle of a signalized intersection. So a priority rule consists of a few different elements. So first up, we have this stop line here, which will be the orange bar. And then this will also have a conflict marker. It can have one or more conflict markers associated with it. And this will be showing up as a green bar. And each of these conflict markers have two main parameters that are associated with them. And then one is the minimum gap time that the vehicle approaching the stop line is going to look at in order to make its decision when it's entering the major traffic flow here. And then the other is the minimum clearance distance. So it's going to really just take a look at these two items to evaluate its decision. And the minimum clearance will also be defined by this green triangle. So you can easily see when you're looking in the network editor kind of where that clearance distance has been defined. All right, and then so when a vehicle is at the stop line, again, it's going to look at two different conditions in order to determine if it can proceed or not. So it's going to, as it reaches that stop line, it's going to look at that particular conflict marker that's associated with that stop line. And the first thing it's going to do is look at the approaching vehicle's current gap time. So the amount of time it's going to take the front of this vehicle to reach that green conflict marker. And then it's also going to take a look at the physical distance, so that current headway that it has between the front bumper of the vehicle and then the conflict marker as well. So it's really going to look at both the time and the distance in order for that vehicle to reach the green conflict marker. So if the approaching vehicle has a current gap time that's less than that minimum gap time that's been defined, or if the headway of that vehicle is less than that defined headway or clearance time, then the vehicle is going to stop at the stop line and not proceed. Otherwise, it will continue going. So here we have just a couple of different examples. So in the first example, this vehicle is traveling about 30 miles an hour. And so its gap time currently, we're at 150 feet upstream of that conflict marker. So it's got 150-foot clearance and then about 3.4 seconds of gap time. And if we compare those to those minimum values that have been set, we can see here that the definitely good on the headway, 150 feet is greater than 30 feet. And then its gap time is also greater. So we have the current vehicle going to have a gap time of about 3.4 seconds, whereas the minimum gap time is 3 seconds. So in this case, since both of those fall above those minimum values, that yellow vehicle will be allowed to proceed and enter into that main traffic flow. And then in the next example, if we take a look at our yellow vehicle here, at this time, the blue vehicle is much closer. So as the vehicle has reached the stop line, in this case, the headway condition is still met. The vehicle is 90 feet out compared to that minimum of 30. However, in this case, the gap time is only going to be about 2 seconds, which is going to fall below that gap time, the minimum gap time of 3 seconds. So in this case, since the vehicle gap time criteria is not met, that yellow vehicle is going to wait here at the stop line until that vehicle has fully passed that conflict marker, and then the yellow vehicle will be able to continue moving. So again, you can kind of see that the conflict markers have a few different configurations that they need to be set up and kind of configured. So again, these are more flexible than the conflict areas themselves, but you can see they would be a bit more time consuming to set up and use. All right, so in order to place the priority rules, first you'll just select that from the Network Object toolbar. And then you can either right-click on the link itself and then open up that context menu and click Add New Priority Rule. And that will set, again, that orange stop bar for the vehicles on the minor flow. And then you can just left-click at that point to add in the green conflict marker. And again, those conflict markers, you can have multiple of them to a single stop bar. And so this will kind of be like adding in a routing decision where you can just left click and add in as many priority rules as needed. And then alternatively, you can also just press Control and right click to add in that orange stop bar. And then again, you can just left click to place all of those conflict markers in the network. And then once those priority rules have been placed, they will have an object window that's going to open up automatically. And so within this window at the top is the number and the name of that particular priority rule. And then the left side of this window is going to contain all of the information for the stop line attribute. So within this section of the window here, you can see that the stop line can either be defined for all lanes. So if you did have a multi-lane link, you can create a single stop bar across that entire link, or you can just set it up for a single lane. And then you can also see the position here on that link that the stop line is located. Directly below that is a driving direction dropdown. And so for the most part, this will always be set to forward. But if you are doing any sort of like parking space modeling where vehicles may be backing up or reversing, that's kind of where that reverse drop-down item will come into play, mostly for those parking spaces when the vehicles are reversing out of them. And then you can also set up different vehicle classes for which this particular stop line will apply. And then you can also choose whether or not this particular stop line will be active for a particular signal state. So this will allow you to choose a signal group and then the state of that signal, whether it's red or green. And this condition can sometimes be useful if maybe you don't need all of the vehicles or when all the vehicles are required to wait and not observe some vehicles that are located at the stop line of a red signal controller. And then on the right side here, we have all of the conflict marker attributes that are associated with that priority rule. So again, these are pretty similar up at the top. You can either set that conflict marker for all of the lanes on a particular link or just for a single lane, as well as that position. And then you can also set up the different vehicle classes that will apply to. And then down near the bottom, this is where, again, you can set those important criteria here, so that minimum gap time and then the minimum clearance distance. And what's nice about that clearance, if you remember, that's also noted with a green triangle in the network editor. So once you have that placed, you can also click and drag the green arrow as well, so that way you don't have to go ahead and measure out the distance all the time. So that will just allow you to easily edit that clearance distance within the network editor itself. And then you can also set a maximum speed value as well. And so any vehicles that are traveling toward the conflict marker, those will only be considered if their speed is below this value. And by default, this is set to a really high value. You can see here 111 miles per hour. And since this default is so high, that's just going to mean that any vehicle, mostly any vehicle that's approaching that conflict marker, is going to be considered. So you can set this to a lower value if you want to adjust that parameter. Okay, so that kind of covers all of the yield control using the conflict areas and priority rules. So the final section we're going to look at today is on the stop sign object. So within Vissim, a stop sign acts the way a stop sign is intended to operate in the field. So in this case, any vehicle approaching the stop sign, they're just going to decelerate to 0 miles per hour. And then they will stay there for at least one time step. So they'll just come to a full stop. And then at that point, then they'll start to accelerate again and continue on their journey at their current speed. So the stop signs don't add any sort of conflict areas or priority rules. So again, these will need to be added in conjunction with some sort of control, especially for modeling a two-way or always stop controlled intersection. And the stop signs in Vissim, again, they're going to always force the vehicles to come to a full stop. But if you do need to model maybe a rolling stop, if you're trying to model a point where the vehicles don't come to a full stop always, instead of using a stop sign, you can use a very small reduced speed area that has a low desired speed distribution. And in that case, what will happen is the vehicles will slow down almost to a stop, and then they will proceed on their way. So that's kind of a way around if you do need to model a rolling stop rather than a full stop. Okay, so in order to add any stop signs to the network, if you select that stop sign object from the network object toolbar, you can then either right-click on the link and click Add New Stop Sign, or you can also just press Control and then right-click to add a stop sign directly. And once you do have one of those stop signs added, they also have an object window that will open up. And you can see here the stop signs, again, they have a number and a name, as well as their link location and their position on the link. And then stop signs also have a couple of other attributes that can be added. So the first one here in this tab is the right turn on red. And so this is where we can actually connect this to a signal controller and a signal group in order to model the right turn on red. And we're going to take a look at this in more detail next time once we talk more about modeling signalized intersections. And then the other tab here is for the time distribution. And so in this case, this will allow you to have vehicles dwell at a stop sign for more than one time step. So this can be especially useful if you're modeling a toll plaza or a border crossing. And this will just allow you to set a longer dwell time at that stop sign location. So in order to add any of these dwell time distributions, if you just right-click within this window, you can select the Add button, and this will allow you to add in that particular class as well as the dwell time distribution associated with that. So this window is very similar when you're setting up like a desired speed decision or a reduced speed area. So again, these are very useful for modeling if you're doing any sort of toll plaza or border crossing where you need those vehicles to dwell for more than just one time step. Okay, so from here, let's go ahead and take a look at our example file. So in here, we do have mostly some signalized intersections, so we'll take a look at those in more detail next time. So we've got 3 here that we'll be modeling with the signal control later on. But we do also have a few areas over here that are not signalized and do need to have some sort of right-of-way defined. And so again, when you are in the network editor, if you do want to see a list of or visually see like all of the conflict areas in the network, if you just select that conflict area object, this will display all of the conflict areas, including the passive ones that get automatically generated. And so you can see that these will get generated, again, at any of those crossing locations. So you can see at any merge location where you kind of have those connectors overlapping, at any crossing location where you have two links or connectors crossing one another, and then also at some of the diverging points as well, where we have like some of these areas where we have kind of like an off-ramp being modeled here. So in order to edit any of these, again, you can just click on the conflict area network object. And then let me zoom in here to one of these conflict areas. So if you left click on the conflict area, you can then right click and change the status using that window. Or you can also press Control and then right click, and this will allow you to just quickly cycle through each of the different states. And this is just a nice quick way that you can just visually kind of see, okay, this link here has the major flow, so we've got green defined there, so they'll have the right of way. And then you can see here that we've got the minor flow link here, so those vehicles are going to yield to the vehicles with the right of way. So yeah, just holding Control and right-clicking is a nice quick way that you can easily configure some of these conflict areas. And then again, you can also view these conflict areas if you right-click on them and click Show List. And that will bring up a list of all of the conflict areas, including the passive ones within the network. And this is also where you can further define some of those other attributes that we talked about, so the front and rear gaps. So you can add in some additional safety distance factor, or you can also have vehicles observe adjacent lanes or anticipate routes. So let me move over here to this small area. So in this case, we have, this is just has a single stop sign here, and then these two links have the right of way. So again, here you can either just Control and right-click on the conflict areas to define the priority for each of these individually. And then another option that I wanted to show really quick, let me just set these back to passive, is the ability to just do that automatic conflict area generation. So again, here in the Network Editor toolbar, if you go over to that toolbar on the left-hand side, you can just click that Define Major Flow button here at the very top. And again, this will open up this other window here where you can choose to set the conflict areas. And once this window is open, you'll have kind of a little circle here with a cross in the middle. And this will allow you to first left-click to select like kind of the start point of this Define Major Flow. And then you can just click and drag until you reach the end point. So this can be particularly useful if you do have multiple intersections kind of lined up and you want to just define the major flow for all of those all at once. And so then once you click on that, you'll be given a little preview here of what the settings are going to be. And so all of the conflict areas will kind of show up with this hatched pattern. And so this will just allow you to quickly see that these conflict areas will be automatically generated by this particular tool. And once you're set and want to confirm this change, you can then just click on the green check mark here, and that will exit that particular wizard, and then you can see all the different conflict areas that were automatically generated here. And with this tool, it will also generate the kind of these diverging conflict areas as well. And this is just so that if in any case there was ever a backup that was occurring, those vehicles would still be able to see each other and would not overlap with one another. So in this case, like if the westbound through was backed up and a vehicle was kind of sitting here waiting, the vehicle that needed to make the westbound right turn would just sit behind it and wait until that vehicle has continued on and would not overlap with that vehicle at all. And so again, once you have these automatically defined, you can just easily and quickly check them. And if there was something that didn't get generated or something you wanted to change, again, you can just update that quickly just using that Control right-click to change all of those different settings. Okay, and then in this case, if you did want to add a particular priority rule, if you select that object from the toolbar, again, you can then just press Control and right-click to place that stop line, which will just show up as an orange bar. And then you'll also have that ability to set in those conflict markers. And these conflict markers can be added more than one. So if you have one there, so let me click OK, you can then keep adding those, and those will all be associated with that one stop bar that we just placed. So if you did have different conditions that you need to set for a particular priority rule, you can set separate conflict markers with different clearance times or gap times if needed. You can also, again, if you just double click on one of those conflict markers, it will open up that priority rule window for you. And if you do want a vehicle to consider all of the lanes along that conflict marker, you can change that setting again to all lanes. And you'll see here that that will automatically create a single bar for that entire link. And in this case, all of these, this priority rule will just contain these settings that are set, so they'll all be combined within that one conflict marker. And again, you can also update that clearance distance either directly within this window, or you can also take that conflict marker and you can also just drag it if you want that. It's sometimes a bit easier to change that distance using a conflict marker directly rather than trying to set the distance and measure it. So this is just a quick way that you can quickly change that clearance distance. Okay, and then finally, for any stop signs that we have in the network, if you just select that stop sign object, again, you can just either control and right click to add a new stop sign, or you can right click and choose add new stop sign here. And so again, these don't have a ton of different parameters for them. They mostly are just going to be a stop bar where the vehicles will physically come to a full stop. But you can also set up that right turn on red, which we'll cover in more detail next time. Or you can add any time distributions if you do want vehicles to dwell for longer than one time step. Okay, so let me go ahead and remove some of these extra stop signs, and then you can go ahead and play the simulation. And you can see here that since we have some of these defined, that vehicles will be able to see each other. Whereas before, when things are kind of set to a passive conflict area, those vehicles would just kind of overlap with each other and not be able to see each other. But in this case, you can see, especially here, these red vehicles will acknowledge the vehicles on the major traffic flow and wait for those vehicles to fully pass before continuing on their journey. And again, if you do have any of those stop-controlled intersections, you'll just want to make sure that you add those conflict areas or priority rules as well, since those stop signs in and of themselves don't add any sort of right-of-way or priority control.